Okay, now we're going to do applying a function to each element, to each list element. Now I'm going to give a very artificial example here. Suppose that we're talking about a website and we're talking about the page hits per hour. And this is very artificial because this is day 1, day 2, day 3, day 4, and I just used this simple concatenation operator to do this, which makes it very artificial because it just goes like in the first hour it was 1, in the second hour it was 2, in the third hour it was 3, all the way up to 10, which doesn't really make sense. And then also artificial is that it was I'm just saying, suppose out of the first 24 hours of the day, only the first 10 hours received any hits, and the second day the first 15 hours received hits, and the first hour got 1 hit, the second hour got 2 hits, third hour got 3 hits, and so on. So it's very artificial. Day 3, 1 through 8, and day 4, 1 through 12. But just for this example, I'm going to leave it like that. So this is a list, and if I try and view it, I get this, right? Now suppose I want to apply, remember we said we're interested in applying a function to each list element. So the list elements, remember, are D1, D2, D3, and D4. Not these. These are not the list elements. These are within a particular element. This is what they contain, but these are the list elements. So we want to apply a function to this, to this, to this, and to this. So as another arbitrary choice here, let's suppose we want to calculate the length, which is obvious already, but suppose we want to calculate the length of D1, D2, D3, and D4. So we want to apply the length function to each list element. So we're going to use a function called list apply. So it looks like this. Looks like this L apply. And we have to give it the list that we want to use. So this would be and then we have to tell it the function that we want to apply to this list. So like I said, suppose we want to calculate the length of each of the elements in the list. So that means we want to apply the length function. And you don't have to use brackets for the length function, just like that. And we get this result. So what was the length of the first list element? 10. Second length was 15. Right there, 15 elements here. Third one was 8, and the fourth one was 12. So we get this. Suppose I want the average for each of the elements. What could I do? I mean the mean. I could do this. Okay. Suppose I want the standard deviation. And so on. So if I have a list, and it can, and remember lists, number of elements in each element doesn't have to be the same. Number of entries in each element doesn't have to be the same. So here we have 10, 15, and so on, and we can apply the results here, and we get things like this, or like this, or like that. Now suppose that I store the results of this in a variable, and then I do is.list try it. It's a list. As you can see, the result is a list. Now there's an alternative to the L apply, and that's the S apply. Okay? I'm doing the same thing. S apply to the, I'm applying it to the same thing. But the result, whereas before the result looked like this, now the result looks like this. So sort of the same result. But this is not a list. Let's put it in the result. Let's print out the result. Again, we already did that, but what happened to it? Oh well. Anyway, let's see what the result looks like. Looks like that. And let's try. Is the result a list? No. So what is it? Is the result a matrix? Nope. What is it? It's a vector. So in this case, the S apply gave us a vector. It returned a vector. And the S in S apply stands for simplify. And so it tries to simplify the result. And so instead of sending returning a list, it tries to return either a vector or a matrix, which is simpler than a list. Now, in this case, the results that were returned were just numbers. This number, this number, this number, and this number. So therefore, we got a vector as the result. However, if what was returned was a vector and a vector and a vector and a vector, all of the same size, then the result would actually be a matrix. And so we would test, and this would have been true, and this one would have been false. Okay, when would it return a matrix? So let's go back and check this out. See what we had at the beginning here. So what was it? We had page hits per hour. We had it was a list. The first list element was this one, and it had these entries. The second list element was this one, it had these entries, and so on. So if I put page hits per hour $D2, I would get this element, right? Let's try that. So page hits per hour $D2 should give me this list element. So let's try that here. So we get that, right? All right, let's, there's another function we haven't seen before. We've seen the mean, we've seen the standard deviation, we've seen the median. We haven't looked at this one per se, but it's a very simple function, even easier than any of those. And it's just, if you do, let me do it this way. Sorry, range. So if I do this, so I'm just asking, this is page hits per hour D2, so that's this. And the range is just the smallest value and the highest value. Okay, like that. It's a little bit different than we say the range, what we mean by the range in statistics, where actually by the range in statistics we mean 15 minus 1, we mean 14. In other words, but here the range just means this and this, so it's the smallest element and the largest element. Okay? So this is a function, right? Now just before we used S apply, which was to simplify, on page hits per hour, and we got a vector returned when we applied this function SD. And that's, we would have, if we did, just to review it, if we did L apply, we would have gotten a list, but when we did S apply, we got a vector. Now, however, that's partially because SD just returns one element for each for each thing that it's fed, it returns one element. So we fed it the whole D1, and it gave us the standard deviation of that. We fed it the whole D2, and it gave us the standard deviation of that. Now, what about instead, if we instead of putting this into standard deviation, we put this into the range function? So we just saw that the range function doesn't give us just one element. It doesn't return just one element. It returns two. So it returns 1 and 10. It returns 1 and 15. So if we apply, if we did what would happen if we did sapply page hits SD? Sapply page hits per hour range. If we did SD, we got this, 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 and this. But now we're not going to get just one element for D1. We're going to get two elements. We're going to get like whatever it was, 110 and 115 and whatever this one was and whatever this one was. I think it was 112 for this one. So that's not, can't give us a vector in return, right? It can't, because it's two elements here, two elements here, two elements in here, two elements. So if we use sapply, it's going to simplify it. If we use, remember, if we use lapply, it's just going to give us a list, period. But if we use sapply, it's going to try and simplify it, and it's either going to give us a vector if it can, but if it can't, in this case it can't, it's going to give us a matrix. So let's just see that. So what do I have to do to find that result? Sapply here. Okay, so now, but instead of SD, which is going to give me just one element per list element, which means I'll get a vector in the end, but now I'm going to do range. Again, I don't need brackets for the range function here. Okay, and so I do that, and now I do result. See what I got. And I don't get this kind of thing, which is just a vector. I get a matrix. Okay, so to summarize, what does this do? If you do lapply, you get a list back, where this gets applied to each element in the list, to each list element in the list, right? To each list element in the list. But if I do sapply, then it tries to give me either a vector or a matrix. Okay? Notice that the original list, the list elements were not necessarily the same, so we don't have to have that. Okay, so we applied a function to each list element. The next thing we're going to do is apply a function to every row of a matrix. Okay, so we did list apply and sapply. That was to lists, to a list. But suppose we have a matrix, we want to do something kind of similar. In this case, we're going to apply something to every row. Maybe more similar would have been, say, to apply it to every column of the matrix, but first we're going to start with applying it to every row. Then we'll do every column, the next one.